Hello students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is solving of logarithmic equations, and in our today's sessions the logarithmic equation we will be having a single question solved in this session. We will be learning the rules. We will be solving the given logarithmic equation. We will be understanding the given rules and we will be solving the given logarithmic equation using the given rules. How to solve a logarithmic equation when there is an integer? I have written presence of an integer, but there may be multiple integers also present in the given equation. Since it is a logarithmic equation, there will be logarithmic terms, of course. But along with the logarithmic terms, there will be an integer or multiple integers present in the equation. In our today's session, the question that we will be taking up will be having a single integer, but you may have multiple integers present in a logarithmic equation. And of course, I'll be telling you what to be done if you have multiple integers. Okay? So without any further delay, let us start with our today's session. First of all, let us look at the given question. Question is, you have to solve log of x plus 3 minus 2 equal to log of x. And since the base is not given, the base is equal to 10. So over here in this question, we are having a single integer, but you can have multiple integers. The question could have been, say, log of x plus 3 minus 2 equal to log of x plus 1. Or in place of plus 1, any other number. So in that case, you will be having multiple integers in a particular logarithmic equation. Okay? So coming to the very first rule. Bring all the terms containing log to the left-hand side of the equal to sign. And how do we do that? Because this log of x is on the right-hand side of the equal to sign, we have to bring it to the left-hand side. How do we do that? We add negative log of x to both the sides. So that on the right-hand side, we have log of x and negative log of x added together will be giving us a 0. They will be cancelling each other. Okay? And since we are not having the plus 1 part in this equation, the right-hand side will become equal to 0. But if we had log of x plus 1, then it would have been equal to 1. The right-hand side would have been equal to 1 if there was a plus 1 on the right-hand side. Okay? So it is not that after taking the logarithmic terms to the left-hand side, the right-hand side will be equal to 0. It may be equal to 0. In this case, it will be equal to 0, but it may be equal to some other number as well. Okay, so if you are having some number on the right-hand side, it will be staying on the right-hand side. So the right-hand side will not be equal to 0 in every case. But for this question, of course, it will be equal to 0. So first of all, let us move this log of x to the left-hand side by adding negative log of x to both the sides. We get log of x plus 3 minus log of x minus 2 is equal to 0. Rule number 2. The integer should be on the right side of the equal to sign. Now, since this question is containing a single integer, I have written the integer. But in reality, you have to take all the integers. All the integers should be present on the right-hand side of the equal to sign. And they should be added and subtracted together, simplified to give us a single number. There should be a single number present on the right-hand side of the equal to sign. If you have multiple integers, get all the integers on the right-hand side. How do we get all the integers on the right-hand side? Like this minus 2 has to be taken to the right-hand side. What should we be doing? We will be adding plus 2 to both the sides. So we actually add or subtract numbers of opposite sides to both the sides of the equal to sign to get rid of or eliminate the undesired numbers and take them to the other side. Okay. So in case you had plus 1, we are now taking 2 to this side, minus 2 to this side, so the sign will change and it will be a plus 2. And if you have plus 1 on the right hand side, it will be 2 plus 1 equal to 3, and we will be writing this is the logarithmic expression on the left hand side, equal to 2 plus 1, that is equal to 3. We have to add the two terms so that we get a single number on the right hand side of the equal to sign. Okay. So now for this question, it is log of x plus 3 minus log of x is equal to 2. Coming to the third rule. The integer is equal to integer times 1. This 2 can be written as 2 times 1. And the 1 can be written as log with the same base as the other terms. The base is equal to 10, so it will be log to the base 10, and the argument will be equal to the base. So we know that log of a to the base a is equal to 1. So we will be writing this one or this one as log of 10 to the base 10, since the base is 10 in our case. Whatever is the base, you take log of that number and the base will be the same number. Okay? Because log of a to the base a is equal to 1. So first of all, we write 2 as 2 times 1, and in place of 1, we write log of 10 to the base 10. So it is log of x plus 3 minus log of x is equal to 2 times log of 10 to the base 10, which is log of 10. Fourth rule, make the integer the power of the argument. Actually, you have to, in this case, it is just this term which is having some coefficient. Make the integer means this one, the power of the argument. This is written in terms of with respect to this particular question, but what you have to do actually is wherever you are having a coefficient which is not equal to 1, you have to take that coefficient and make that coefficient the power of the argument. Over here, these two terms contain 1 as their coefficient, so you don't have to do anything. You can just take this 2 and write it as the power of 10. But in case you have coefficients for these terms which are not equal to 1, you have to do the same thing to these two terms as well. If this was 2 times log of x plus 3, you would have taken this 2 and made 2 the power of x plus 3. Which is essential because you have to have a coefficient of 1 in order to combine log terms using the laws of logarithm. Okay. So for this question, since the coefficients are equal to 1, we do not have to do anything to this side. We just make this to the power of 10. And it becomes log of x plus 3 minus log of x is equal to log of 10 to the power of 2, which is equal to log of 100. Okay. So coming to the fifth rule, combine all the terms of the left hand side of the equal to of the equation or the equal to sign, which are all log terms, to a single log term. So this will be equal to log of x plus 3 over x, because we are having a minus sign in between. This is equal to log of 100. And since we are having log to the same base on either side of the equal to sign, we can cancel these two logs and we can equate the arguments. So this will be the next rule. Equate the arguments of the two log terms of the either side and solve them. So it will be x plus 3 over x is equal to 100. And now we can cross multiply and we will be having x plus 3 is equal to 100x or 99x. If we subtract x from both the sides, it will be 99x equal to 3. And next we divide both sides by 99. We get the x value as 3 over 99 or x equal to 1 over 33. Let us see whether we can take this value of x. 1 over 33 plus 3 will be a positive number. 3 and 1 over 33, that is 100 over 33. It is a positive argument, so it can be taken. Even this equal to log of x, 1 over 33 is a positive number greater than 0. So it can be taken, this value of x can be taken as our answer for this logarithmic equation. Okay. Always check for solving, whenever you are solving any logarithmic equation, always check, always substitute the answers that you have given in the given equation and see whether you can take those answers or that particular answer, whether you have to reject any answer or not. Okay. So students, this was all for this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.